Every part of our day depends on a reliable source of energy, from the first cup of coffee, how we commute to work, heat our homes, and keep the lights on. The UK is the first major economy to set a net zero target by 2050. Impressive? Yes. Challenging? Absolutely. Achievable? Only through dramatic transformation of our entire energy system, how we generate, use, and store it. Welcome to Energy Matters, a regular podcast highlighting the issues, challenges, and opportunities of the energy industry to make sure we secure supply, demand, and a low-carbon future. Brought to you by Atkins, a member of the S&C Lavalin Group. My name is Alicia de Haldevang, and I'm hosting this episode called Engineering Net Zero. This year, Atkins published a new report titled Engineering Net Zero, an extensive research project investigating what the UK's net zero energy system will look like. From increased energy generation, the use of hydrogen, carbon capture and storage, system integration and optimisation. In other words, our current supply, how much we need to build between now and 2050, which new industries we need to establish, and how all these components work together. I'm joined today by Chris Ball, Managing Director of Atkins Nuclear and Power Business for UK, Europe and Middle East, Dr. David Cole, Market Director for Power Generation, and Andy Thompson, Director of Offshore Wind. So our take is engineering net zero. What is the emphasis on engineering?
Well, I think as an organisation we need to look at what it is we specifically bring to the debate. And obviously out there are a lot of commentators around net zero for 2050 in the UK, but equally around the world. What we see quite a lot of the time is people who are very quick to point out where the issues are, but equally what we cannot lose is the political dimension. And what we have attempted to do in our report is to marry all these things together against the backdrop of what we are, which is an engineering company, to look at not just what the problem is, but how we would go about solving it from a risk-informed engineering perspective. So it's specifically targeted on the engineering, hence why we've entitled it Engineering Net Zero. But Dave, I'm sure you have views as the architect of a lot of this report.
I think what's been really useful as well in that for solving this problem in the feedback we've had is there's been an awful lot of modelling done of what a future system could look like, but not as much work on how you get from A to B and what the challenges will be on the way, like build rate, manufacturing, etc. And that's why we've taken a much more pragmatic view of it to try and help with some of those decisions, which are really hard to make.
And just picking up from what Chris was saying about us being engineers, what's critically important is in our everyday lives, we see what's happening with the overall system. So for us to commentate is, I guess, our safest position in terms of where we feel we need to go to be able to meet the target of a net zero economy by 2050.
So 2050 is only 30 years away. Do you think it's possible that we can reach net zero by then?
I think it's useful just to put a few quick numbers around the size of the challenge. The size of the challenge is going from using 300 terawatt hours a year to 650 terawatt hours a year. All of that in low carbon generation. We've got to go from very little hydrogen generation today to potentially 10 times the amount we're using. And we've also got to increase from nothing significantly the amount of carbon capture we have in our system.
I think the question there is it achievable? I think it is, but let's not kid ourselves. This needs immediate action. And immediate action can quite often be quite difficult in democracies. And if you look, does the general public believe in the size of the challenge ahead of us? On one hand, it would be easy to convince ourselves, yes, they do. On the other hand, every time I flick my light switch at home, the lights come on. And actually that detracts from the message that this is really important and we have to change. I think what we have seen over the last year and a half, and we saw it obviously in the recent general election debates as well, is the importance of climate change and net zero really rising up the public agenda. I still think there's work to do on that. So it's not just a case of immediate action, it's making sure that immediate action is underpinned by the highest level of public support. I still think there's a little bit to go there.
From a technology perspective, I think there's the technologies that we can rely on. So when you look at things like nuclear, when you look at offshore wind, could those technologies take us to 2050 and are they available now? Well, yes, they are. The issue that we've got, though, is with some other technologies that aren't as less developed, that we feel as well are critical to the success of hitting net zero in 2050.
So the Net Zero report focuses on a number of recommendations. The first one being the need for a flexible approach. Can you expand on this a bit more?
If you to look at the national grid in the UK over the course of a year, currently we probably use the order of 300 terawatt hours, speaking in round numbers and the details. Obviously in the report, if we cast our minds forward to 2050 with increasing electrification of infrastructure, and obviously transport is central to that as well, as we highlight in the report and underpinned by the CCC figures, we more than double the size of that grid, about just shy of 650 terawatt hours. So it's moving to 645 terawatt hours of low carbon, carbon-free electricity from the current levels of probably around 150, so about half the 300 at the moment. That is a massive, massive build program. Let's not kid ourselves. Can one technology do it? Well, advocates of each technology could easily convince themselves in their mind that their technology was singularly capable of achieving those levels of increase. The reality of life is, though, in the UK, we are not acting in isolation. The whole world at the same time is looking to decarbonise. It's fantastic that we have been the first economy to commit legally to the 2050 goals, but many other economies around the world are looking at this. So we're going to see demand placed on supply chains, whether it's for offshore wind, whether it's carbon capture and sequestration, whether it's nuclear. So we see that demand really starting to threaten the ability of any one technology of doing it on its own. Alongside that, actually, there are advancements that we'll see in each and every technology as well. So what today might look attractive might be less attractive in the future because of advancements elsewhere. And what's important to us is, I think, firstly, recognising that nuclear, carbon capture and sequestration, renewables all have a massive part to play. And obviously, offshore wind is a big part of the renewables play here. And we must keep the options open in each and every one of those technologies. And finally, actually, from a future stability perspective as well, by having a combination of these different forms of generation, it helps grid stability from 2050 onwards as well. So all those coming together means we must demand a flexible approach, not be closed to any one singular approach, and make sure that each and every one of us and everybody in the public realise the role that, especially from an electricity perspective, each of those three technologies of offshore wind, nuclear and CCS have to play.
Over the last 40, 50 years, we have never built more than around 6 gigawatts of capacity in any one year. What we need to achieve net zero, based on the scenario put forward by the Committee for Climate Change, is a build rate of around 9 to 12 gigawatts a year, which is a massive change. And we can't predict now what we're going to build in 10, 20 years' time.
That is a lot to do. Who do you suggest orchestrates all of this?
That's a very good question. Dave, you've got some views on this.
I think one of the things that we talked about quite a lot in preparing the report across a number of people in Atkins is the role of an energy system architect. And that's because the problem is getting ever more complicated. What you've seen so far is government policy based on the single component of a system, such as the intervention in offshore wind with a contract for difference to encourage and promote that industry, which has worked really well. But what we need now is a body which is capable of making decisions for an integrated system that includes power generation, heat, industry and transport. And unless we are able to start to make some of those decisions, we're really going to struggle to build the right things. And using the wrong measures to judge and determine what we're going to build, such as levelized cost of electricity, which is used today, which is the cost to the generator of building something. As the system gets more complicated, the cost of running the system will increase, and therefore we should look to see what the cost to the consumer is.
It's fantastic that we live in a very free market here in the UK, and I think there's a lot of advantages, and probably all of us over the last 20, 30 years have seen the benefits of that in terms of the electricity prices that we pay on a day-to-day basis. As we start to look forward, though, there are undoubtedly some areas that on a pure commercial basis would be difficult to justify an investment, but we know full well that they will be needed from a stability perspective, backup supplies of varying degrees. I think the role of an energy system architect or similar is really important to make sure that those investments for our future stability of the grid for our children and our grandchildren, that those investments are made.
And I think there's an element that doesn't get included in the net zero discussions as often as it should, which is energy security. Where are we going to get our fuel supplies from? Where are we going to get our electricity from? As Europe changes its own generation capacity, where we're reliant on interconnectors, what risk does that pose to our particular system, for example? So the energy system architect has quite a broad role in the way that we see it, including resilience, including energy security, as well as making decisions which balance all the needs of our infrastructure and societal needs.
Another recommendation is the increase of clean, reliable nuclear power. Can you expand on this a bit more?
There's two key words in there probably, nuclear and reliable, and I'll pick them out. So the reliable firm power, if you look at the grid today, there's over the course of the next 20 years, unless we build some major power stations, there will be a drop off in the firm power, whether that's from gas turbines, whether that's from nuclear. So first of all, we need to look at how we replace that firm power to bring that stability to the grid. Secondly, then, let's look at nuclear for a second. So over the course of the year that we just finished, 2019, I think the low carbon element of our national grid increased by 1%. So a lot of wind farms coming over the course of the year. But actually what we saw is because of some challenges on the existing nuclear fleet, actually the fact that a couple of nukes were spent quite a lot of time offload last year meant that we saw a minimal increase in the low carbon power during 2019. I think just goes to reaffirm the importance of nuclear and really achieving the low carbon targets that are ahead of us. Now, if you look at the CCC modelling, that of course is just an indicative model. It's not saying that this is the only way to achieve net zero. That is assuming somewhere between 8 and 9 gigawatts of nuclear power, which is a combination of 3 new plants at Hinkley, at Sizewell and at Bradwell, coupled with the existing plants at Sizewell. The remaining nukes by then will have closed down. So by the time you look at the importance of firm power moving forward, by the time you add on to that the fact that we need to increase the size of the grid from around 300 terawatt hours a year to well over 600 terawatt hours, and the impact that we saw in 2019, actually, when there was minimal increase in low carbon power with just a couple of nukes being off, they sort of more or less net balance that out. I think it just goes to reaffirm the importance of nuclear in this equation.
The report also mentions carbon capture and storage. Can you tell us more a bit about that? Currently
today in the UK, we capture 0 million tonnes of carbon. We want to go to a system which has a much greater capacity than that, and under the net zero system it's 176 million tonnes per annum. If you look at the CCS net zero scenario, you actually need carbon capture and storage for around 40% of the energy requirements. 28% of that is for electricity generation, and the remaining is for hydrogen generation, because you need to produce a good volume of hydrogen, which requires carbon capture because you're making it, bulk of it, from natural gas. Say for CCGTs, it could be anywhere between 16 and 70 plants that you'll need to be building over the next 30 years. That's actually quite challenging to integrate the technologies together, even though some of them are well known, like amine stripping, and then build that in an industrial cluster. The carbon capture projects you have today are generally collecting carbon from a single source. We will probably need to have systems that collect carbon from lots of different sources, from a CCGT, from hydrogen production, and from other generators of carbon such as industry, and then manage that in a way so that the contracts and the arrangements you have get ever more complicated to try and create this system.
But it's not all about nuclear, is it? The report goes into the need for increased capacity from renewables, primarily offshore wind. Andy, this is your area of expertise.
There's a number of different opportunities that we could take in the UK. So if you look at the different technologies, you've got onshore wind, you've got solar, you've got hydro, you've got offshore wind, and there are other forms as well, such as tidal and wave. When you look at maturity of technology, and when you look at constraints such as planning constraints, maybe on onshore wind in terms of the size of the turbines or the amount of land that we've got for solar, what you do come to is actually if you need large scale build out of renewables, offshore wind is the most viable technology that we should be using at the moment. 75 gigawatts, is it possible? Yeah, so you look at the build rate that we've had over the last few years, so approximately about 200 turbines have been going in per annum. If we maintain that current build rate with large turbines, which I'll come on to in a minute, then we will be able to achieve that 75 gigawatts in isolation.
Another area is heavy investment in hydrogen.
Hydrogen is proposed to be used for heating, for transport, and for electricity generation potentially as well. And that's a massive challenge for what's a gas that's actually relatively hard to produce and also quite hard to store and manage. And there's some massive questions for us to answer about how we want to generate hydrogen, how we want to store hydrogen, and how we want to use hydrogen, and whether that's to manage daily variations or the big ticket challenge for us as a country, which is interseasonal. How are we going to store energy when it's plentiful in the summer so that we can use it for heating, for example, in the winter? Clearly, some people consider, and it could be, that hydrogen is a useful energy storage system for us. However, what gets talked about most is electricity storage, the use of batteries in cars, the use of batteries in electricity storage. And I think it's really important to ground this debate. The technology that we have available to us today is used for managing frequency or short times of energy production, i.e. managing the grid when we have a short blip. It's not used for backing up large generating technologies, and very, very unlikely to be able to do that. We did a short calculation for Bristol, which is if you lost Bristol for 24 hours, you need over 130,000 fully charged Nissan Leafs plugged in to go ready. And it's simply really hard to see a vehicle-to-grid system working in that way. And it's also hard to see the current technology we have scaling up in a way to be able to manage, first of all, daily variations in energy, but let alone seasonal variations in energy. So this debate really has to come out into the open because it's used by various groups in the discussion to say it'll be all right, energy storage is coming.
So we have nuclear, hydrogen, CCS, and renewables. A lot of components there. How are we going to make sure that they all work together?
So one of the principal issues regarding offshore wind is the fact that the very nature of a capacity factor of 58% is that for 42% of the time it's not generating. So from a systems architecture perspective, that other 42%, where does that power come from? So that's absolutely critical. So having a system that the UK totally relies on offshore wind alone won't work. We just won't have the electricity there to provide a stable energy source going forward.
I think one of the things which is a really big challenge for this system is stability, keeping the system stable with the different technologies we're using. And if you look at offshore wind, the proposal under net zero is to build around 75 gigawatts. That's an awful lot of wind, and that's an awful lot of intermittent power. There's a certain amount of nuclear being proposed in this scenario as well, and personally I think that it could be higher to give us a better low-carbon firm baseload. However, the challenges faced by both could be seen to be the mirror image. For offshore wind, you want to turn what is a flexible generation into firm power. For nuclear, you want a firm baseload power to perhaps act more flexibly. You might look at different energy storage systems to make those work together, such as generating hydrogen. And I think it's incumbent on these industries to work together more to create the right system.
And what are the key challenges of these industries? Let's start with nuclear.
Now, each technology, of course, has its challenge, and the challenge with nuclear is the high upfront investment. The capital cost is massive, extremely cheap thereafter to run, so the operating costs are very cheap, but it's the massive upfront investment. So over the course of a full life cycle of a power plant, actually it provides very cost competitive energy. The key though is that investment, the investment shape, the shape of that investment, it's all up front. Or a massive part of it is up front. Hence why there's a lot of government thought going in at the moment about how we overcome that challenge through the regulated asset-based model. Each technology will have its challenge. With nuclear, it is around that upfront investment.
We've discussed the barriers that we need to overcome in terms of the nuclear industry. What are those that we need to overcome within offshore wind?
One of the big drawbacks about offshore wind is that it's an intermittent form of power. So it's not always generating. So currently, the existing wind farms that we created sort of 15 years ago, capacity factors might be in the 30%. The ones we're creating at the moment and building are sort of in the 40%, going into the 50%. What the government is looking to do, quite rightly, is we need to have a capacity factor of about 58%. So is that achievable? So there's a number of things here that we need to do to increase the capacity factors. And I do think they're achievable. So the first one is we need to improve reliability of the actual wind farms. And I guess if you look at any type of technology, there's normally a Bath curve associated with reliability in terms of when something's new, it's a bit less reliable. So you look at things that we've seen in the industry that are pretty well documented, things like grout failure, things like problems with the blades, gearboxes. Those things are starting to be understood now and ironed out as part of the new thing. So reliability will improve. The next thing is about rollout of the larger turbines. So smaller turbines are generally, because they are smaller, they will have lower hub heights. You get more wind the higher you go generally. So the bigger turbines have got bigger blades, they catch more wind, and the wind is more reliable. And from what we're seeing for the future developments which were approved in 2019, certainly the Creek-Beck developments, the GE turbine which is being proposed there has got a capacity factor of 63%, which is above the 58% which is needed.
Apart from creating an entire new industry, what's another challenge that we face with carbon capture and storage?
The cost of capturing carbon is actually not paid for. And until someone's paying for it, there's no commercial incentive or market there to make somebody actually do it.
So engineering net zero is an enormous challenge for every industry. What do you think we should focus on within the next year?
By the end of 2020, I think we need to see a large-scale carbon capture project get off the ground and start to actually go into at least detailed design and potentially construction for us to really understand if we've got a chance of building the amount of carbon capture we need as a country.
So when I reflect on the different energy systems over the past couple of years, offshore wind has been incredibly successful because of the financial mechanism that the government has. And even in offshore wind, you see how fixed offshore wind is accelerated, because that is what the contracts for difference are geared against, whereas floating has struggled. There was a mechanism called ROCs. They aren't available at the moment, and that was to help with innovative technology. So I think what needs to happen in 2020 is clarity from the government to how these various technologies, be it hydrogen, be it nuclear, be it floating wind, how are those going to be helped to get to the 2050 position?
Let's take a look at nuclear. CCC says 8.5 gigawatts. I actually agree. I do think it should be far higher than that. Equally, offshore wind has a massive role to play here, as do broad renewables, but obviously offshore wind and CCS as well. You get the sense at time between some industries that there's a question about which one you belong to. And that's not the right approach here. It's not about the success of offshore wind or the success of nuclear or of carbon capture and sequestration by 2050. It's about achieving net zero. And actually, I think there has to be a call to arms almost for those three different industrial sectors to be working far closer together as we move forward. And you speak about the energy system architect, hopefully they can do that, but equally I think it's incumbent on everyone in the industry just to grab hold of that and do this. If we are to achieve net zero by 2050, the first battle that we need to win is to ensure every single member of the general public is fully on board with this battle. At the moment, I actually don't believe that's the case. I think we are taking massive steps forward over the last 5-10 years in regard to net zero, but I still don't think we're there yet. So for me, I'd probably measure it in terms of how many people in schools are demanding action. What structure has the government adopted that really reinforces the importance of net zero and their commitment to the challenge? So I'd probably be asking ourselves the question. I think it's incumbent on each and every one of us at an individual level to say, what is the behaviour that I'm going to help drive over the next 18 months, 24 months that really helps get the entirety of the UK population on board of this? Because without that, I tell you what, this is going to be bloody hard.
Well, we've certainly covered a huge amount of ground here. Thank you to our panel. Thank you for joining us and listening to this episode. And join us next time. I'm Melissa de Haldevang, and this is Energy Matters.